Welcome to this seminar. I'm Cecilia Katzeff, and I'm an associate professor in human-computer interaction, and I did my PhD in psychology about 30 years ago, specializing in cognitive psychology, and since then I've been jumping back and forth between academia and industry. My research interests capture the intersection of sustainable development, human-centered design, and everyday practices. I'm especially interested in how technology in people's homes is linked to the lifestyles they shape, especially regarding energy use and food consumption, because these are basic functions in our lives. It's also interesting to see how our relationship to energy and food has changed over time. So zooming in on energy, we can definitely see that our relationship to energy has undergone a significant change in history. So in this talk, I will focus on these areas. I hope to cover them. I will talk about smart grids and a particular project that we're carrying out right now, studying the roles of households in smart grids. I will talk about the touch points between smart grids and households, because this is sort of the basis, the foundation of the project. We'll have some concluding remarks and hopefully a question and discussion if there are more people joining, but you're, of course, both of you are welcome to formulate questions. So the background, what is a smart grid, to start with? There is no internationally accepted definition of smart grids, and I won't try to define it, but instead highlight a few key characteristics describing smart grids. The smartness of smart grids consists in digital technology being used to collect, measure, and act upon data in the grid. And the major environmental sustainability aspect of smart grids lies in their function to integrate renewable energy into the system, such as solar and wind power. But there's also another sustainability aspect, which is not always considered, and that's the social sustainability aspect, the capacity of the electrical grid. Because if the capacity is insufficient, people won't be able to use electricity in the obvious way that we're used to. Access to electricity is actually one of the cornerstones of our welfare society, and we've been used to electricity always being present behind the two holes in the wall. But this might change through the intermittent delivery of renewable energy and also through the increasing congestion in the power grids. So this is where the next significant characteristic of smart grids enter the scene. That is flexibility. Balancing the load in the power grids. In the smart grid, the supply of electricity will fluctuate. So electricity consumption will need to adapt to the hours of the day when the supply is high and steer away consumption from when the supply is low. The fourth feature of the smart grid is its major touch point to households, and this is the pink one. In addition to smart meters measuring electricity use with a very high resolution, there will be technology in the homes that visualize, automates, and controls households' electricity use. And to say something more about the close encounter with people, I'd like to mention a few areas which often recur when we discuss smart grids and households. To some extent, they all have to do with the potential of households to become a more involved part of the energy system. And dynamic pricing, dynamic invoices can be used as an instrument to control households' energy use. And the visualization of energy use is a question attracting a lot of attention, and there's an increasing market for companies using data from smart meters to form services and technologies to communicate to the households. The automated home, also referred to as the smart home, is a home that allows households to be passive. All functions in the home are optimized with a view to efficient energy use and are set automatically. And devices in the home are also envisioned to become more and more connected. And this is usually referred to as the Internet of Things. And that will play a major role in the future electricity grid. And we can probably see machines in our homes which communicate with each other to optimize electricity use. Microproduction of electricity is when households themselves produce electricity, usually from solar panels that they themselves use, store or sell, not the solar panels, but the electricity that they produce. And flexible behavior is one of the central points of our project too. That's talked about in connection with load balancing. And we will learn to adapt our use of electricity to reduce the load on the grids and to increase the use of renewable energy resources. What is missing in this picture, but are also important to mention when you talk about the close encounter with people and smart grids, are aspects of privacy, policy issues, and also, of course, theoretical frameworks. And I won't I'll just mention them. I won't go into detail talking about them. So I think these are appliances, prototypes that Sophie recognizes because they were developed at the Research Institute, the Interactive Institute, where both me and Sophie have been working. I was there for 15 years in a group called Energy Design, and colleagues of ours designed the power aware cord and the energy aware clock. And the power aware cord was also made a commercial product. The experiment that we did with developing these prototypes is the point of them was to visualize energy use in an ambient way, which could be present and domesticated into people's homes. The picture to the left, as I said, showed the energy aware cord, and that uses a water metaphor to visualize the flow and effect of electricity. It was designed by Anton Gustafsson and Magnus Gyllensvärd. And the picture to the right shows the energy aware clock, which was designed by Love Broms and Karin Amberger, who actually worked at KTH right now. And the aim here was to create an object that would facilitate the comprehension of electricity use in the home. Just like a normal kitchen clock, it would be visible and centrally placed in the household. And the aim was, as I said, to facilitate the comprehension. So now I could talk a lot about the energy aware clock because we did a user study in homes of the energy aware clock, but it's not the point of this presentation. So instead, I'll turn to the research project, the current research project, which is called Stories from the Homes of the Smart Grid. And I've given some background to the motives driving the development of future electricity system, the smart grid. And in this current project, we wanted to dive deeper into issues dealing with the role of private households in the smart grid and how they will be affected by the new socio-technical system. We're a team at KTH and Uppsala University now. In this research project, you see Miriam Boyson Rivera, who was at KTH, but she's now at Uppsala. My colleague Björn Edin and Sophie is also present in the Zoom window here. And then there's me, both Sophie and me, we work in the ABE school. And the project receives funding from the E2B2 research program from the Energy Agency and IQ Samhällsbyggnad. So the empirical base for this case study is the Ellevio's pilot rollout of 4,000 new smart meters in Stockholm. This picture is from a meeting with the press just before the summer of 2020. And you can see Ellevio's CEO, Johan Lindehag, and also the municipal Commissioner of Finance in Stockholm, Anna König, to provide households with data from the smart meters. Ellevio also provides a service visualizing electricity consumption data, and I will talk more about that later on. This is the main character of our research project. No, it's not. It's actually the households that are the main characters of our research project. But this is the condition. I just want to say something about this new smart meter and the technology provided, or the functions that it provides. As you can see, the high hopes are put into the meter, as it is expected to provide households with knowledge, not only data. So this, the quote here was said by Ellevio: the new smart meters will provide customers with a better insight into their electricity use. They will also be able to use electricity in a more climate-friendly and cost-efficient way. So these are the hopes expressed by Ellevio. And the meter has a lot of functions, not all being used right now, but it's prepared for integrating micro-production of solar power and also for feedback services. The function of automatic control of demand-side management is a function for the future, but probably not so far in the future, if we interpret the voices that we hear in the policy documents, which I will talk about in a moment. So the purpose of our project is to study how visions of stakeholders and actual practices in the homes correspond. So interviews and observations were made, or are still made, through the analysis of policy documents, communication with stakeholders, and interviews with households in their homes. So here are some questions in focus. What are the visions and goals of stakeholders? And what are the implications for differences in households? How do stakeholders' expectations and actual practices in their homes correspond? And what are the values for households in balancing their use of electricity, their own values for being flexible? And also we want to look into what happens to the dynamics in a home when new technology is introduced, such as this smart meter. So the picture to the right is representative of a typical house in the Älvsjö area. I don't know whether this particular house was there, but small houses mostly built in the 30s. And as this flag shows, we're still analyzing results. So we're not done with everything yet. So this is sort of a test of our present result up to now. So this part is something that Sophie has been looking into a lot, stakeholders' expectations. And as I said, we have two ways in collecting stakeholders' expectation, and it's both from policy documents, and we've also made interviews. We haven't finished the interviews or we have finished the interviews, but not the analysis of the interviews with stakeholders. So I won't talk about that now, but instead I'll mention the policy documents. So let's see. Oh, sorry. Sophie Nyström, as I said, led this analysis of the policy documents, and they reveal a lot of interesting issues. We were guided by something called the WPR approach, formulated by a researcher called Carol Backe, and she formulated this approach in 2016. And WPR stands for what is the problem represented? And by identifying suggested solutions to a problem, it's possible to make inferences about the problem itself. And for this task, 33 policy documents were identified as interesting for our search because they contain text about the role of households in the smart grid. And we looked for views of households in the smart grid, how are problems represented, the problem representations, and how private households were viewed as part of the solution. And here you can see some examples of the policy documents that were collected. There were, for instance, there were reports from the Swedish Smart Grid, Energy Markets Inspectorate, and also government official reports. So this is my summary of the views of households as a solution. They are part of the solution by being flexible and active. And this is what is mentioned in the reports. And by being interested in their own energy data and act upon it, by accommodating household activities to optimal times during day and night, by interacting with home energy equipment and services, and by allowing automatic control of equipment. And main equipment being mentioned are heat pumps and electronic vehicles, and also by producing their own electricity, and they are supposed to be motivated by financial incentives. So you have to excuse me, Sophie, that I'm quite quick in summarizing this, but I want to move on to the silences. The material is very rich, and we're going to have some very interesting results and discussions on the material. But this it's also part of the WPR framework to actually identify what is not mentioned in the policy report. This is a useful aspect of the WPR framework, which identifies gaps intended to, and it's also intended to be an instrument to move research forward. What is not mentioned actually identifies research gaps. So some of the things that we have been discussing in our group, and when we have seen what these policy reports talk about, is that they hardly mention heterogeneity of households, the difference between households, and they don't mention the consequences for the dynamics within households, the division of power and responsibility within households. They don't mention how they are supposed to communicate the societal problems with energy and electricity to the households, although they discuss it a lot in the reports that it is a problem, but they don't have a communication strategy. They don't talk about the participation of households, although they emphasize that it's important that everybody's part of the energy system and that this also includes the households. They don't have a strategy or a method to actually work with households in including them in the system. And this, of course, connects to democracy and inclusion and power aspects. They don't talk about risks, although we can see in the research literature there are a lot of risks associated with smart home technology. Privacy, security, hacking, and technical reliability, obsolescence, and of course usability and acceptability. So there are a lot of things to discuss. So moving forward, I don't know how I'm doing with time. Okay. To connect the stakeholder visions with, oh, sorry, I was trying to move the Zoom window a bit. To connect that to the case study of the households, it sort of captures the purpose of the study, that we have the expectations of stakeholders on the one hand, and what it looks like in practice. What do people do in their homes on the other hand? So we were interested to see how how these expectations resonate with what is actually happening in homes. So because of that, we focused on differences in the homes, the smart grids, and we were focusing also on the dynamics and the values in being flexible. So to do this, we did an empirical case study where we interviewed, we did Zoom interviews because of the pandemics with 16 households in the pilot area, Älvsjö. They had all had the smart meter, the second generation smart meter installed. And we asked them also how the meaning of this smart meter was communicated to the households. We asked them, among a lot of other questions, of course, about their use of smart home technology, their attitudes to external control of their equipment. Also, again, still analyzing the results. Just to remind you about the expectations and the point of the smart meter, I repeat this slide a bit, but also adding the feedback service. So the smart meter was installed in just before the summer, or the summer of 2020, and then a year later, they also got a feedback service, which was developed by Ellevio together with a company called Bright. So this feedback service was supposed to visualize the data which was gathered through the smart meter. And this is a service which they could download, which households could download from App Store. So how did they communicate the smart meter to households? This is a campaign, a broad campaign from Ellevio referring to the implementation of the second generation of smart meters. It preceded the implementation, and the message here is quite clear. Do nothing. We take care of it for you. You may just relax. So this is in Swedish, but it's quite attractive photos, by the way. So this is a contrast to what the policy reports were saying about households being active through contributing with their flexibility, electricity use, actually being active. But these photos communicate something else. And so this was a broad campaign. So we were interested in hearing what people in the households that we interviewed, what they had heard when the meter was being implemented. So none of the households that we interviewed had experienced any communication, personal communication with them of the goal with the smart meter, nor the functionalities that characterize its smartness. So here you can see some of the statements that are translated from Swedish. So the red ones were the ones saying that, well, there was no communication in essence. And one was saying here that there was a lot of hype before, I think referring to this communication campaign, but they were bad at telling us how good the meter was. We haven't heard anything. And people even tried to ask the people who installed the meter, and they said, just read on the homepage, go to Ellevio's website and you can read about it. But there were two people, or at least two households standing out. And these two were interested in finding out more about their electricity consumption and took own initiatives in exploring the possibilities with the new meter. One of the persons that we interviewed described how he, on his own accord, found documentation on the interface to the smart meter on a Dutch website so that he could open it up and download data. So there was put a lot of energy into that. I'll move forward to the feedback service. The purpose of this app was to provide the households with information on their electricity consumption and also on the climate impact on their consumption. So these are just a few of screen screenshots from the app. And our second session of interviews with the households focused on how the household experienced this app. There were a few problems in the use of it, and we have shared these with Ellevio. On the whole, households saw value in receiving the type of information promised by the app, but there's a need for customized information for particular households and not estimations of consumption from comparison with similar houses and size of households. So there were a lot of not real data. People wanted real data, and these were not real data. Maybe it will be developed in the future. We don't know. I'll just quickly move to some snapshots on the relation to smart technology, which is one of the things that I read our interviews again, and I identified some things and compared them to the literature. So these are there's an illustration of the response to the question. I've drawn some sort of staircase here. And the staircase is inspired by the research literature on smart homes. Marikian and colleagues wrote a paper in 2019 reviewing the smart home literature from the user perspective. And they suggested this categorization of smart home. And the lowest level is a traditional home with very few smart devices. And the highest level is the so-called interconnected homes, where homes in a certain district are connected to each other. Like areas, they're interconnected areas. As you can see, the homes in our study were divided between the 3 ground levels in this staircase. 6 of our households had very few smart devices. In 5 of the households, the technologies were bundled together, and in 5 households, they also had systems that interconnected, but they were, I found none of our households were in the top 3 levels here. And let's see. Just to mention what smart home technologies were used for in our case study. These were the areas. There were security, like alarms, locks and cameras, lighting, TV, music systems like entertainment, watering. People have their own greenhouses and they use smart technology to automate the watering. Controlling washing machine, vacuum cleaning like robot vacuum cleaners and lawn mowers, surveillance and, surprise, child rearing. So this might be something that we were quite surprised about, but that's another story which we will write a book about later on. Probably. And we're still analyzing. There's a lot of results here. So I think I've come to the to say some concluding remarks about our study. And it's most of it actually resonates with results from a previous study that we made, that Sophie also was part of, a literature and interview study of user involvement, which we made in 2018. That study was called Smart Grids for Whom. Here we saw a strong technical focus in pilot projects where smart electricity networks were installed in homes. Social science or behavioral science competence was seldom involved in the development of systems that were to be used by private households. And there was a dominant focus on technology and economics. It also turned out that some of the projects users were seen as an obstacle rather than an important resource in realizing the smart grid vision. Obstacles, for instance, were that users want to protect their privacy. They didn't have time and interest, and they had difficulty in changing their habits. So these were the obstacles identified by technology developers. So a final note and question to take with us on the journey of developing smart technology for the home is a warning, which is formulated in the question, are we designing for research man? Jolande Strangers is a sociologist in Australia who has published a lot in the area of smart energy and people. And her resource man is very well known and represents the energy industry's resource bias projected onto energy consumers. She refers to resource man as a male, not because he's always directly identified as one, but because he is, I quote, cast in the image of the male-dominated industries of engineering and economics that permeate energy management. Resource man is interested in his own energy data. He understands it and wants to use it to change the way he uses energy. He responds rationally to price signals and makes informed decisions based on up-to-date and detailed data provided about the costs, resources, units like kilowatt hours, and impacts, greenhouse gas emissions, for instance, of his consumption. For these tasks, he needs information, dynamic prices, and enabling technologies. I think the criticism the Strangers resource man carries towards the technology-focused discourse surrounding the implementation of smart grids in society needs to be taken seriously. So, using the social practice theory lens might be a fruitful way to go. Just to finish off, if you design for resource man, you risk of missing everyday life where energy use is included. So thank you very much.